synthetic substitution. If you're wondering what other substitution that you would have done in the past, you would have done what was called direct substitution. Direct substitution, here I'll do that real quick with a different function that I've got here. Okay, so a direct function would have been, let's say I've got the function f of x equals x plus 2. And I want to put in a 3. Direct substitution is just putting it in. 3 plus 2 gives me 5. Again, that is direct. And that's not like it's a bad thing, but I'm going to show you a little trick with synthetic substitution that might make the operations a little bit smaller and easier to do when you're dealing with, third power, second power, first power. So first of all, put the x value outside in a little bit of a box like this. So if I want to put in x is equal to 4, there's where my 4 goes. I'm going to put all the coefficients, make sure it's in standard form, so x to the third, second, first, and then my constant. So 5, 1, -4, and 1. And I'm going to put a little acronym over here. It's called drop mama. What I mean by drop mama is I'm going to start this off by dropping the first coefficient down. And this number in the box is my multiplier. So I'm going to take 4 times 5, and that's 20. So there's the m for in mama, and then I'm going to add. So there's your a. And I'm going to do the same thing. 84. And then add. So multiply and then add. So that's why the mama part, multiply, add, until I finally get to the last spot. And I would get 321. That means the function, when I put in 4, would spit out 321. Okay, so here we go. Let's try this again, synthetic division. But this time what I'm going to do is I'm going to kind of skip. It's going to go from the 4th power to the 3rd power. Here's my number off that I'm going to substitute off to that side in that box. I've got -3, but I'm going to put a 0 because there's a 0x to the 3rd term. Kind of like my matrix equations, I need to have a placeholder for the coefficients. We got 2, -3, and 4. So drop, multiply, add, multiply, and then add, multiply, the -34, add, and -30. So f of -2 gives you -30. Okay, didn't have to take a number to the 4th power, didn't have to take a number to the 3rd power, 2nd power, any of those upper level powers. I could get my answer with synthetic substitution. Okay, I'm going to try another one again. Here, let's put in the 4. Okay, be careful. I got 3. I've got -1. There is no x to the 3rd. There is no x to the 2nd. So I am going to have to put 2 zeros this time. -5 and 10. So drop, multiply, it was just 12. Add together, it's 11. 44. 176. Okay, 176. 176 times a 4. There's 2, there's 0, there's 3, 704. 609. 609 times 4. 63. So there's 3, 2, 4. Add them together, and I get 2,446. There we go. Again, I had to do a little bit of long multiplication because I couldn't do it mentally, but again, I'm not taking some astronomical number to the 5th power. So here's how this all helps me out. I'm going to use this to kind of make my table, and I'm going to graph my 1 minus x to the 2nd minus x to the 3rd. Now, we talked about end behavior in the last lesson. Because it's a cubic, it's going to look up on the right side, down on the left side. but because we've got a negative for an A value, it's going to be a reflection. So I know at some point over here, my graph is going to go up. Over here, it's going to go down. Okay. Again, I'll take my synthetic division. I'll go -1, -1, 0, and 1. Make sure that you put them in standard form and have a placeholder for that x. Okay. Put in -2. Multiply, add, multiply, add, multiply, add, and I get 5. So -2, 1, 2, 3, 4, and 5 is 1 point. Okay, do the same thing with -1. Now, this isn't a parabola, so don't think it's symmetrical. Okay, there we go. Get over here, buddy. So 1, 0, 0, 0, and 1. If I were to put in 0, I'm not going to do that. I'm just going to do direct because 0 will make all those go away, and I'm left with 1 as well. Okay. Very easy to mess this up. So if I made a multiplication error, because I'm going really quick, let me know. But I'm just dropping a number, multiplying, adding, multiplying, adding, and I get -11, which is good because remember we talked about our end behavior. It's going up in that direction and it's going to go down over in that direction. So that is end behavior.